This video is for Unit 1, Lesson 1 of Algebra 2A. It says it right there. So here's your learning targets. You can read those. This is kind of a summary of what we are looking for here. What we are looking for is a solution to a system of equations. So solving systems of equations. So the first thing you want to remember or know is that a system just means two or more lines. Okay? I would add this to your notes. So a systems of linear equations is two or more lines. And a solution would be the point where they intersect. So a solution is when they have a coordinate point that is a solution to both lines. So an x and a y, a point that lies on both lines, the point where they intersect. So if you have a solution, you describe the system as consistent. So you can see these first two we say are consistent, and this last one we say is inconsistent. So I'm going to talk about 1 and 3 first. So this one is clearly has an intersection point. So we say it's consistent and independent. Independent means one solution. So that kind of makes sense. If you're independent, you do things alone. So independent means one solution. So I like to think of these lines as like two friends. So these are, maybe these you could think of as two acquaintances. They don't do a lot together, but they do one thing together. Maybe they play a sport together, or they play the same musical instrument. This is consistent and dependent because actually what this is the same line. It's two lines on top of each other, so the graph looks like one line. So this is two friends who do everything together. They have every single point in common, so they're very dependent on one another. So you can notice here it says same line, infinitely many solutions, and this says one solution. Inconsistent are two people who really don't know each other. They don't intersect, and the lines are parallel, and there's no solutions. Remind yourself that parallel lines have the same slope. Okay, these two lines will have a different slope. These will be the exact same lines, so the equations will be identical. Say something like this. They'll both have the same equation. Okay, so we're going to learn in this unit 3 methods for solving or finding the point where they intersect. So your solution is a coordinate point in xy. So finding the xy intersection point. Okay, the first one we're going to learn is by graphing. So we simply graph these two lines. We see if they intersect. When you're graphing them, you got to graph them pretty carefully because you have to find that exact point where they intersect. So this is slope-intercept form. So my slope is 2. So I'm going to think 2 over 1, just like to put it over a 1, so I know I rise 2, run 1. And this is my y-intercept. So my y-intercept is 3. So I start with the y-intercept, so I want to go to y equals 3 and put a point. And from that point, I want to rise 2, run 1. So I'm going to go up 2 over 1. I'm actually going to switch to pencil here. Up 2 over 1. And remember, you can go down and to the left also. So I'm going to put a few points. I'm going to carefully graph this. I'm not sure, I might need more points, but for now I'm just going to put those. And I'm going to graph this one. So this has a y-intercept of 3. Well, there we go. I just found my solution. That's the point they have in common. But let's graph the entire line. And then this one I'm going to go ahead and put arrows on. Make sure you're always putting arrows on your lines. This one has a slope of negative 1/2. So I'm going to go down 1 and to the right 2. So I go down because I have a negative slope. So there's my graph. My solution is this coordinate point, so my solution is over 0, up 3. And then is it consistent or independent? It has one solution, so it's consistent and independent. Okay, let's check out another one. So example 2, same thing, we need to graph them. You'll notice this one isn't in slope-intercept form. You have a couple options here. I notice that 3 divides into 9 and 3 divides into 9, so I can graph this using the intercept method. Or you can put it in slope-intercept form. So I'm going to use intercept method first, which I like to call cover-up method. So I'm going to cover up the x term, and I'm left with this equation, negative 3y equals 9. So if you think about solving this equation, you would divide both sides by negative 3, and you would get y equals negative 3. So that's my y-intercept. So I'm going to go down to y equals negative 3 and put a point. Now I'm going to cover up the y term. Let me do it this way. And I'm going to get 3x equals 9. So if I divide both sides by 3, I would get x equals 3. So that's my x-intercept. So that's my line here. It looks like I go up 3 over 3 is my slope. 1, 2, 3, 1, 2, 3. So I can graph that. Now, if you don't like that method, you can do algebra on this and get it into the form where y is alone. So I would minus 3x from both sides first. Always trying to get y alone, always get rid of what's furthest from the y. On the left I have that. On the right, those are not like terms, so I just have negative 3x plus 9. Put your x term first because that's how slope-intercept form looks. Now, negative 3 multiplied by y, to undo multiplication, I want to divide everything. Make sure you divide everything. Negative 3 divided by negative 3 is 1, so those 1 out. Negative 3 divided by negative 3 is again 1, so that's just going to be x. Positive 9 divided by negative 3 is negative 3. So this is a y-intercept of negative 3, which I already have graphed, and a slope of 1. Right, that invisible 1 in front of that x. So up 1 over 1, up 1 over 1, up 1 over 1, so this is my line. Okay, this one, y-intercept of 1, right here, and a slope of negative 1. I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. So there you can see, right here is my intersection point. So my solution is the coordinate point over 2, down 1. So x is 2, y is negative 1. So if I have one intersection point, then I have a solution, so I'm consistent. One solution is independent. So consistent and independent. This one's a your turn, so I'm going to let you try that one. And then this is going over doing it on the calculator. So you can obviously do this on your calculator. You're going to do y equals, you have to make sure your equation is in slope-intercept form first. You're going to go to the y equals menu. I'm going to punch in 2x plus 3. And then zoom 6 will give you a standard window. And then you find the intersection of your equation. I'm going to show you, I have a slightly different calculator. I don't know where my other one is right now, but I think, looks like my battery's dead. Well, this will have to be, I'll put this one in a separate video and I'll get my calculator going.